Hello and welcome. In this lesson, we will look into scatterplots and learn how to analyze them in order to identify whether they represent linear or nonlinear relations. Remember that scatterplots are graphs that use dots to represent individual pieces of data. As you can see in here, the dots plotted on the Cartesian plane are scattered. They may form a trend, but they're scattered and not connected to each other. And that's where the name scatterplot comes from. A word that we use very often when analyzing scatterplots is the word correlation. Correlation is a statistical measure, and it is used to indicate the extent to which two or more variables fluctuate in relation to each other. So let's take a look at the following relations and discuss what correlation means to each and every one of them. Always keep in mind that in this lesson we are focused on linear relations. And as we have learned in the previous lessons, a linear relation can have a positive slope or a negative slope. In this case, we say that the scatterplot may represent a positive linear relation or a negative linear relation. If you look at the first graph, all the data are lined up perfectly and follow a line. So that means that if I were to draw a straight line to connect all the data, I'd be able to draw a single line, a single straight line, and the line will touch each and every single data. In this case, we say that we have a perfect correlation, and it's positive because the line is going up. So a perfect positive correlation. When we look at the next scatter plot, we can tell that the data will follow a trend, a linear trend. But if I were to draw a line to show the trend followed by this data set, I will not be able to hit all the data with my line in here. So I'll be able to probably touch most data, but not all of them. For example, not this one, and not this one here, and not this one here. However, the data that are not touching the line are still close enough to the line. And in this case, we say that we have a high correlation between the data because the linear trend is quite clear. And it is a positive correlation because the line is going up. So a high positive correlation. In the next set of data, if you were to enclose all the data in a line, curved line, you can tell that there is somewhat a linear relation. But if I were to draw a line that is as close as possible to all the lines, then you can tell that most data are unable to touch the line, or the line does not touch most of data. It does describe the trend, but it can't touch most of the data. In this case, we say that the correlation is low. And it's a positive correlation because it seems that this data set is following a positive trend, is going up in value. Now, when we look at the next graph, if I were to enclose them in a line, you see that we have formed in here almost a circle. In this case, we are unable to see whether the data is following this trend or is going down or is simply horizontal. In this case, we say that there is no correlation between the data set in this scatter plot. In the next graph, as you can see in here, we have a data that is following a negative trend. And if I were to draw a line to describe this trend, the line won't hit most of the data plotted. So in this case, we say that there is low correlation. and it's a negative correlation because the line is going down. When you look at the next graph, the data are a lot closer to each other, and if I were to draw a straight line to describe the trend, I would say that I'd be able to connect with most points or to hit most of the points on this scatter plot. In this case, we say that we have a high correlation, and it's a negative correlation because the line is going down. And when we looked at the last graph in here, or last scatter plot, if you were to draw a line, to describe the trend, then we would say that we'd be able to draw a line that can touch almost every single data. In this case, we say that we have a perfect correlation, and it's negative, obviously, again, because the line is going down, or the trend is going down. Now, in the next part of this lesson, we are going to learn how to draw the line of best fit. So, the best strategy that I suggest to draw the line of best fit is what is called the area strategy. The line of best fit, remember, is a line that goes through the scatter plot of data point and best expresses the relationship between the points. Now, the area strategy consists on enclosing all the data in a circle or an ellipse or a shape in more generally. So once we enclose the data in a shape, here we go, we try to draw a line in the middle of the shape. So a line that divides this area into two equal parts. And this would be the line of best fit. Now, drawing the line of best fit can be a little bit tricky because there is no single accurate answer. And the answers may vary a little, but they may still be good lines of best fit. Now, the division strategy is another strategy that we can use to draw the line of best fit. And for this, I use the same data set as I have in the previous example, where we use the area strategy. So what we do is we look at the ends, both ends of the data, and I would look at this part in here and this one in here and try to find the middle and put a crosshair wherever the middle is between the data. And when I say the middle, you see the distance between the data is the line that connects them. And this would be the middle. This would be the middle. And then I connect the two crosses, okay? And I would say that this would be the line of best fit. Now, this is called a division strategy because in a way we kind of divide the data between the data above and data below the line. And once you draw the line of best fit, then you want to count how many points you have above and how many points you have below. Ideally, we want to have an equal number of data on each side of line of best fit. Now, one very, very, very important thing to remember is that it is not necessary for the line of best fit to pass through all the points or most points. Sometimes you may have a data set and draw a perfect line of best fit that doesn't touch any of the points even, okay? So the line of best fit needs to describe, or the mission of a line of best fit is to describe the trend of the data and not to connect specific or particular data in your data set. Now, the next question you're probably wondering, and that's why I put this down here, is why do I have to study the line of best fit anyways? Well, once we draw the line of best fit, we would be able to describe or to predict data that are not in the graph. For example, this data was collected based on a certain population. And we have not, for example, population of Ontario, for whatever study that we are conducting. And we have not surveyed the whole country. So by knowing what the trend is in Ontario, we can predict the trend in the whole country. So, and that's how the line of best fit would help us, because the line of best fit can be described by an equation, and we can use that equation then to determine the values of data that are outside our data set. Now, when we do this, we call it extrapolation. So extra means outside the range of our data. And extrapolation means to collect data outside the data range. Now, another way that we find studying the line of best fit very useful is the line of best fit can help us determine the values in between data. For example, if you notice here, we have data here and a data here, but we don't know exactly what's going to happen at exactly this point, right? So a line of best fit can help us predict what will happen in between data. So what the values will be for each variable x and y. And this is what we call interpolation, because we are looking for data inside our scatter plot, but we weren't specifically given that data, so we don't know the exact value. So we can predict it by using the line of best.